Ancient giants unearthed thousands of 210 million years old dinosaur footprints discovered in Italian mountains. A remarkable paleontological discovery has been made in northern Italy, where thousands of dinosaur footprints, some dating back 210 million years, have been found on a remote mountainside in the Stelvio National Park, nestled in the Freli Valley near Italy's border with Switzerland. Now let's dig in and break this story wide open on the AI podcast.
Okay, so when you think about finding, I don't know, a massive cache of 210 million-year-old dinosaur footprints, where does your mind go?
You're probably thinking a desert, right?
Yeah, exactly. The red sands of Utah, maybe an old riverbed somewhere in Africa. You definitely picture somewhere flat.
And that is precisely why this discovery is so mind-blowing. We are talking about thousands of tracks. Thousands. And they're incredibly well preserved.
Mm-hmm.
But they're not on some horizontal plane. They're etched into a nearly vertical wall of rock.
A sheer cliff face.
A sheer cliff face stretching for hundreds of meters high up in the Italian Alps.
It's the ultimate expectation-defying location. And that's why our deep dive for you today is to unpack this whole story of these Alpine giants.
Mm-hmm.
We'll get into the incredible geological forces that put them there, how these dinosaurs actually moved, and maybe the most surprising thing of all, what these tracks tell us about their social lives.
And you really have to appreciate the scale and age here. These aren't just a few random prints. It's an immense scientific treasure trove. It gives us this rare, clear window right into the late Triassic.
A period that's usually pretty murky for us.
Very murky. But here we have this archive of ancient life just laid out on a rock face in Stelvio National Park. It's a total paradox.
So the big question is, how did they get there, and why are they still there?
Right.
Which takes us straight into our first section. This idea of a geological time warp.
Let's set the scene. The discovery was made in the Freli Valley. It's a very rugged, remote part of the Italian Alps, right near the Swiss border.
But the key to this whole thing, for you, the listener, is realizing that what you see now is not what existed then.
Not even close. What we see today are these huge snow-capped mountains. But back then, during the Triassic period, say 210 million years ago,
It was completely different.
the entire region was a low-lying tidal flat. Just think of like massive mud flats, maybe a coastal lagoon. The ground was just perpetually wet and muddy.
And that wet mud is the perfect recording medium, isn't it? It's soft enough to take an impression.
But then, if the conditions are right, it dries and hardens into mudstone before it can all wash away. The prints get locked in.
Okay, so the impressions are locked in. But that leaves the biggest question. How does a horizontal mud flat become a vertical wall of rock?
Now we have to zoom out from the dinosaurs to the scale of continents. This wasn't just a little earthquake.
We're talking plate tectonics.
We are talking about the slow, brutal collision of continents over millions and millions of years. The African plate was just ramming into the Eurasian plate.
And our mud flats are caught in the middle.
Right in the middle. That whole layer of sedimentary rock with our perfect footprints was subjected to just immense pressure. It was folded, pushed up, and tilted almost 90 degrees.
So, just to be clear for everyone listening, the dinosaurs were walking on flat ground. Then the collision of two continents basically took that entire slab of Earth and stood it up on its end.
That's it. It's a monument to geological violence and a miracle of preservation. The fact that the process didn't just shatter these fragile impressions is, well, it's extraordinary.
It makes the discovery story itself even more incredible. I mean, how do you even spot something like that?
It took a very, very keen eye. The find was made back in September, and not by a paleontologist on a dig.
No.
It was a nature photographer, Ilio della Ferrara. He was just out surveying the rugged terrain, looking at the mountain, and he spots these strange rhythmic patterns on the rock face.
You have to imagine that double take, realizing those patterns were made by a dinosaur.
Can you imagine? I think the reaction from the experts says it all. Cristiano Del Sasso, an expert from Milan, he called it extraordinary and an immense scientific treasure. He said this place was full of dinosaurs.
Full of dinosaurs. I love that. It wasn't just a few passing through.
No, it was a busy place. And that density is what makes it such a critical scientific site.
Okay, so let's pivot to the animals themselves. Who made these tracks? This is our second deep dive. Decoding the prints and the prosauropods.
Well, the quality is just fantastic. You can see these long parallel rows of prints, and some of them are huge.
How huge?
Some measure up to 40 centimeters. That's about 15 inches across. And the detail is so good you can clearly make out toes and in some cases even sharp claws.
And that detail is how we know who left them.
Exactly. These prints belong to prosauropods.
So tell us about them. They're sort of the ancestors of the big long necks, right?
That's right. They came before the true giants, like Brachiosaurus. But don't let the name fool you. These were not small animals. They were huge herbivores for their time. Long necks, powerful bodies. They could get up to 10 meters or about 33 feet long.
A 33-foot animal wandering around on what's now an Alpine peak. It's just wild. But the tracks tell us more than just their size, right? They tell us how they moved.
Yes, and this is where it gets really interesting. From their skeletons, we've always sort of assumed prosauropods were mainly bipedal. They walked on two legs.
Unlike their later four-legged descendants.
Exactly. But these tracks add a really crucial piece of nuance to that picture.
And that's the handprints. I saw that in the research. They found handprints next to the footprints. Why is that such a big deal?
Because it moves us from a hypothesis based on bones to definitive proof of behavior. If they were strictly two-legged, you'd never see handprints.
Right.
The fact that they're there suggests a more dynamic way of moving. It means they could, drop down to all fours when they needed to.
So you can picture this 33-foot animal walking upright, but maybe when it's grazing on low plants, or maybe just needs to rest its weight.
It would pause and plant its forelimbs on the ground. Precisely. It gives them what we'd call a flexible or facultative quadrupedalism.
It just paints a picture of a much more versatile animal.
It does. It's a key insight into that evolutionary journey from these earlier two-legged forms to the massive four-legged sauropods of the Jurassic.
And if the individual tracks show us how one animal moved, the sheer number of tracks must tell us something about their society.
Oh, absolutely.
Which brings us to our third, and I think most fascinating, deep dive, the social secrets hidden in the stone.
This is really the heart of the discovery. What the researchers figured out is that these prosauropods were not just wandering around alone.
They were in herds.
They moved in coordinated herds. And this is some of the earliest, most concrete evidence we have for that kind of complex social behavior in this lineage.
But it's more specific than that, isn't it? The evidence points to a very particular kind of social interaction, defense.
Yes.
Yeah.
If you look at certain areas of the rock face, the tracks don't just run in straight lines. They form these distinct, almost perfect circular patterns.
And that pattern is the key.
Researchers interpret this as the animals gathering together defensively.
We have to stop and really visualize that. You're looking at a fossil of collective anxiety, a herd of 33-foot clawed animals circling the wagons. What could have been so scary?
Well, the late Triassic had its share of formidable predators. But whatever the threat was, the pattern itself reveals this highly developed survival strategy.
Putting the biggest ones on the outside.
Yeah, and protecting the smaller, younger animals in the middle. It's an instinct you see today in modern herd animals, like muskoxen or bison, when they're threatened by wolves.
It's incredible. You're looking at a rock wall in the Alps, and you were basically reading a police report of a defensive maneuver from 210 million years ago.
It's a direct connection to the raw act of survival. But studying this in the present day is a massive challenge.
Because you can't just climb up there with a tape measure.
Exactly. The site is so remote, so inaccessible, you can't even get there on a normal hiking path.
Yeah.
And you risk damaging the impressions.
So what do they do? How do you study it?
This is where modern tech comes in. They rely heavily on drones and remote sensing technology.
So high-resolution photos.
More than that. We're talking about advanced photogrammetry and even LiDAR mapping.
That's the laser mapping tech, right?
Right. The drones use lasers or overlapping images to build these incredibly precise 3D models of the entire rock face. So researchers can measure the depth, the angle, every little detail of every single print.
All from a lab without ever setting foot on the fragile rock.
It's the perfect bridge between ancient life and 21st century science.
And that's not the only bridge, is it? The Italian Ministry of Culture pointed out a really unusual modern connection.
They did. They noted that the site is actually near areas that are set to host events for the upcoming Winter Olympics.
That's quite a juxtaposition.
It is. The ministry called it a symbolic bridge between past and present, combining nature and sport.
So you'll have elite athletes performing these incredible feats of strength right next to this geological monument that chronicles the survival of giants who lived before the Alps even existed.
It really gives a new meaning to the phrase, standing on the shoulders of giants.
It really does. Which brings us back to the photographer who found the tracks, Elio della Ferrara. He said he hoped the discovery would spark reflection in all of us.
I think that's the perfect takeaway. We've gone from a wet tidal flat to an alpine peak. We've seen evidence for a flexible way of walking and most importantly, this powerful evidence of social defense.
It wasn't just finding footprints, it was finding a frozen moment of Triassic society. So what does this all mean for you, the listener?
Well, if this immense geological process could preserve one fleeting moment, a dinosaur herd gathering for defense, and then lifted onto a mountain where it was only spotted by one person's keen eye,
It makes you wonder.
it makes you wonder what other profound moments of ancient life are hidden right under our feet. Or maybe not under our feet, but in the vertical walls that we never think to look at that closely.
The Alpine giants prove that the most amazing stories aren't always buried deep underground. Sometimes they're just waiting for the right person to look up.
So keep looking up and keep digging deep.
Okay, one question for you. What makes the discovery of these dinosaur footprints in Stelvio National Park so significant? Don't forget to comment it. Thanks.